Okay, this is the video about how to graph exponential functions. The standard form for an exponential function is y equals a times b to the x plus c. Each of these numbers tells you something about the graph. C tells you where the horizontal asymptote is. A plus c tells you the y-intercept. And then b tells you whether or not the graph is going to be growth or decay. If b is greater than 1, it's growth. If b is, whoops, that's a d. If b is in between 0 and 1, so if b is a fraction, then that's going to be decay. Okay, so here's an example. Y equals 4 times 1.05 plus 3. So draw my graph. The horizontal asymptote is going to be at 3 because c is 3. The y-intercept is going to be at 7, 4, 5, 6, 7, because that is a plus c. And this is going to be a growth function because the base 1.05 is greater than 1. So the graph is going to look like this. And that's it. Okay. Next example. Y equals negative 2 to the 1/3 x minus 4. Okay. Horizontal asymptote is going to be at negative 4. Come on. Okay, so for a second, what I'm going to do, so notice that there's a negative out front of here. It's a negative 2. For a second, I'm going to pretend that I'm graphing the function positive 2 times 1/3 to the x minus 4. If that were the case, it's not, but if it were, then the y-intercept would be at negative 2 right here, because a plus c is negative 2. And it would be a decay function. The base is 1/3, which is less than 1, so it would look like this. Okay. However, in the equation, there is a negative sign out front. So what does a negative sign do? It creates a vertical flip, right? So what's going to happen here is that when we put the negative out front, the whole graph is going to vertically flip over this horizontal asymptote. So instead of the y-intercept being at negative 2, it's now going to be at negative 6, because if you add negative 2 plus negative 4, you get negative 6. And then the whole graph is going to be flipped so that it looks like this. And the green graph is the final answer. Okay, random technological error. Sorry about that. Okay, next problem on this page. Okay, the horizontal asymptote is going to be at negative 2 because of this, the negative 2. The y-intercept is going to be at positive 3 because a plus c gives you positive 3. This is going to be a decay function because the base is e to a negative exponent. So e is the base we use for continuous growth or decay. If e is raised to a positive power, that's growth. If e is raised to a negative power, that's decay. You can also check in your calculator if you do e to the negative 0.8, which I'll do right now on mine. You get 0.449, which is a number in between 0 and 1. So again, that goes back to the rule that if the growth factor is a fraction, it's decay. So anyway, we just need to draw a decay function in here. So decay starts high and gets lower, and it approaches the horizontal asymptote. Okay, so for the test, you're going to need to know how to write the equation of an exponential function given 2 points. So sometimes you're going to be given a graph, sometimes you might be given a word problem that tells you 2 points. Here's an example of a graph. This is the easier version because you can read the y-intercept off of the graph. The horizontal asymptote is on the x-axis, so that automatically tells you c equals 0. There's nothing added or subtracted, so we are trying to fill in just y equals a times b to the x. Since we can see the y-intercept, we automatically know a. A is equal to 3, which means that now we know the equation we're looking for looks like y equals 3 times b to the x. Now that we know that, we're going to use the other point that was given over here to plug in for x and y. So this point is 8, 6, right? So I'm going to plug in 8 for x and 6 for y. Right? And now I'm going to solve for b. So I'm going to divide both sides by 3. Good God. You get 2 equals b to the 8th. I'm going to take the 8th root of both sides to get b by itself. According to exponent rules, the 8th root is the same thing as raising both sides to the 1/8 power. That's how you can put it in your calculator. Okay. So when you raise both sides to the 1/8, you get that b equals, okay, so I'm going to my calculator, 2 raised to the 1/8, 1.0905. So for our final answer, we get y equals 3 times 1.0905 to the x. So if you've done modeling, this models a quantity that starts at 3 and grows by about 9.05% per period. Okay. The second type of problem you'll see about this is a little trickier because they don't automatically tell you A by giving you the y-intercept. So you just have 2 points and you have to figure out what the equation is. In all of these problems, the horizontal asymptote is on the x-axis, so c is always going to be 0. So you're just trying to fill in y equals a times b to the x. Okay, so we're going to use each point to set up an equation. So we're going to set up 2 equations. This is the ratio method. Okay, so the first point, 20, 50, that means I plug in 50 for y. I plug in 20 for x. Okay, so that's where I got the first equation from. Now I'm going to use the other point, 40, 25. So when I plug in 25 for y, I plug in 40 for x. Okay, now that I have 2 equations, I'm going to divide one equation by the other, or take the ratio of the 2 equations, hence the name of the method. Okay, when you do that, the a's cancel out. 50 divided by 25 on the left-hand side is 2. And then b to the 20th over b to the 40th. Using exponent rules, you get 1 over b to the 20th. All right. Now we need to solve for b. With a little algebra, you get b to the 20th equals 1/2. So now I need to take the 20th root of both sides. Again, that's the same thing as raising to the 1/20th power. To do 1/2 to the 1/20th, you have to use a calculator. And you get that b equals 0.9659363. I'm writing out a ton of decimal places because in exponentials, if you round, it can make a huge difference in your answer. So if you can, in your calculator, save that number, because now we need to go back and plug in for a. You can choose either one of the 2 equations you started off with. I'll choose this one. 50 equals a, and so now I know what b is. And when we plug in for x, that was to the 20th. So I'm going to raise that number to the 20th. Okay, coincidentally, in this case, all right, and then to get a by itself, you divide both sides by 0.5. and you get that a is equal to 100. So your final answer is y equals 100 times 0.965963 to the x. And that's the final answer. The most common place people get derailed on this problem is in the setup. Especially if there are fractions involved. So sometimes this is not this problem, but this is the way another problem might be set up. The two y values you get might be something like 1/2 divided by 3/4, right? Just remember when you're dividing fractions by each other, it's the fraction in the numerator times the reciprocal of the fraction in the denominator. And you get 2/3. Fraction mistakes are by far and away the most common thing that that people miss in the first steps of setting up this type of problem. But other than that, that's it.